in one language and then linearizing it to the other language. And this goes via the abstract syntax. So you have the same set of trees for L1 and L2. And this model...
Is this like Melchuk's deep syntax?
Yes, I think that there are many things. There is Melchuk's and there is Xiaomian's and there is the UNL and there is the Rosetta project using Montague kind of trees, and there are many previous things for this. So here you can see how a compiler works. So on the left upper corner you have a Java expression 2+3. Then you parse it into the abstract syntax tree, which is in the middle, and then you generate JVM, Java Virtual Machine assembly code from that. Or you could, in the GF model, you could have other concrete syntaxes, so English here and then Finnish here, and they all have this compositional relation to the syntax tree in the middle, and you could do translation from any corner to any other in the same way. How you write the grammar? So you have a separate module for abstract syntax, which are the tree building functions, and for concrete syntax you have the linearization rules, and one rule for each language. So here, as an example, EADD is a function that takes two expressions and forms yet another expression, and it is a tree forming function. And then the linearization rule is defined by cases on the abstract syntax constructor. So for EADD of x and y, you take the linearization of x, concatenate with the plus token, and then concatenate with the linearization of y in Java to get the infix notation of Java. And for JVM, you do the same way, but you use the postfix notation and put the IAD token after.
Do you have the Finnish one?
Yes, I will show it.
Okay, good.
Yes. So, and for English, you have some kind of prefix mixfix notation. This is how multi-source, multi-target compilers work. For instance, the GCC, the GNU compiler collection, that you have abstract syntax which you try to share, or at least as much of it you try to share for as many languages as possible, so that you can do the main part of the work, for instance, semantic checking and optimizations on this common ground just once, and then you can plug in a parser and a generator and you get many different compilers from the same system. And the way we use it in GF, and in particular in the MOLTO project, is that we have an abstract syntax and then we plug in many languages. So these are the MOLTO languages, and then we do translation by using abstract syntax as an interlingua, as is maybe the word in translation, in the translation world. So, to Fran's question, so I could write something for Finnish here as well, but it would be immediately something wrong, because it would not take care of the fact that yes, the case.
That's what I was interested
in seeing. And that's what I want to show now.
Okay.
So, if you think that maybe I will show one more thing. So, if you think that this is an context-free rule, so you have x plus x. Then for each context-free rule, you actually extract a pair of rules in GF. So one is the fun rule for the abstract syntax, which you get by forgetting all of the terminals here. And then the lin rule, linearization rule, which you get by, well, putting the terminals back. But then you use variables here. And you see from this, so actually all kinds of operations are permitted here. So you can, for instance, shuffle the order, you can reduplicate something, you can omit something. So as such, it is a very general rule format. And you can, for instance, immediately see that you can define the copy language in this way by just repeating an X. But then this is still just on the level of concatenating strings. And the next thing we want to do is that we generalize the types of the linearization from strings to records and tables, as we call them. So if you have, for instance, noun, we have the abstract category n, and for instance a function man, which is an abstract entity in the type noun. Then the linearization type in French, for instance, is a record where you have the table for the two forms of man, the number forms, and then a field for the gender. And then, for instance, if you write it all out explicitly, the lexical entry, which means the linearization rule for man in French, looks like this. So you have a table with two branches, and then you have the record value for the gender. For Finnish, we can use the same abstract category and the same abstract function, but we change the linearization type, so we don't have any gender anymore, but we have a table that takes two arguments, a number and a case, and produces a string. And then, well, you hardly ever need to write this table, fortunately, because there are very many cases here.
And possessives.
Yeah, so then this is, you have all kinds of things that you can have here, but basically you see the point, so you have all the cases here, and it's a very different kind of object than what you have in French, but it's still, the abstract syntax is the same. So you can also see the linearization types in the same way as if you are familiar with Montague grammar. So Montague semantics for an abstract syntax assigns a domain of possible denotations to each of the types in the syntax. And this is the same way we do here. So this is a kind of a Montague semantics, but interpreting the trees as objects in this space of records and tables. So each type has its own linearization type, which is its domain of denotations, and then there is a set of compositional rules that produce objects of these types, and which are also type checked to actually to do this. The feature system is then also used for agreement. So actually we see not only words but also complex phrases have inflection tables. So the common noun, which is a complex phrase, correspond where just n is the head usually, then it has the same linearization type. It doesn't need to have the same, but in this case it is. And then for adjectival phrases you have two variables, gender and number, and then you have a modification rule putting together adjectival phrase and common noun, and then you get a more complex common noun. And how you do it is that, well, you expect to have a table which depends on number. So this is just the parameter now, so it's a kind of lambda binding here. And you pass it to the noun, which you put before the adjectival phrase, and you pass it also to the adjectival phrase, but the adjective also expects a gender, but this you get from the noun. So this is how the agreement works, that something which is an inherent feature in one kind of category, in one category becomes the value of a parameter in another category. And then you also need to give a gender, so that you just inherit from the head noun. so to say. And a more general rule should also take into account that some adjectives are put before the noun and so on, but I will skip that detail. And in Finnish it goes the same way, but fortunately in Finnish it's simpler because you don't have gender. You only have that both nouns and adjectives have the number and case, and they agree in both of them, so that's how you write it. So this in the end you get, for instance, the inflection table, not only for talo, talon, taloa, but also for suuri talo, suuren talon, suurta taloa, and so on. And all phrases are built in, well, you get the tables for them. So, going back to the idea, so there is this compiler idea that you have an abstract syntax that gives the semantic structure, and the concrete syntax which gives syntactic sugar, as they say sometimes in programming languages. One could also say, quote Roman Jakobson and say that the abstract syntax defines what is possible to say, and the concrete syntax specifies how you have to say it. I'm not sure if it is completely the same distinction, but it comes near us at least. And then, of course, in compilers, the conditio sine qua non is that the translation preserves meaning. So no one would ever use a compiler that doesn't preserve meaning. So that's just completely excluded. And moreover, translation is compositional. That's not always true in compilers, but it's even there. It's important to separate those parts that are compositional from those that are not. And in GF, we basically take care of everything that is compositional. So you can also, this is again, I did this before I saw your slides yesterday, but because we have this as a normal way of telling people how we differ from Google translation. So because we see no way anytime soon to combine full coverage with full precision. So one has to choose, and Google chooses to have a coverage and then increase precision. We choose to work with full precision but add coverage. And this scale is here kind of concepts or things that the smallest units of translation. And if you want to translate everything that there is on the internet, then you have to cover maybe millions of concepts. When MOLTO started, we were having at most hundreds of concepts, and our kind of commitment to the European Commission was to be able to build systems that scale up to thousands. So an order of magnitude, but still a few orders behind Google. And we hope that, well, this is also useful. Well, I think Martin said that the money is where you can, the money is here and not here. But at least there was some European money here. So, so what about this smallness? So that's kind of, it's not just a practical thing, but I think it's more like a philosophical thing, because why many of these interlingua-based ideas have not worked so well is that there is no such thing as a universal interlingua that would give us the full precision of all kind of translation. And we don't want to wait until we have one, but rather we build domain grammars for things that we know, well, this kind of translations we can work with, and we build a translator for those. Well, weather report was a good example of such a domain. But we want to do it in an efficient and principled way, so that we, and I will show what that means, so that it will not be too costly to build these domain grammars. And so this is the slogan that I have seen too many times already, but we see the Rosetta Stone as a boulder field rather than a monolith. So the framework idea, and actually this comes from theorem provers also. So there are many of the successful systems do not work on one uniform formalization of mathematics, but they rather have separate formalizations of different parts of mathematics and different logics and so on, and that's called the logical framework. So technically GF is really a grammar formalism built on top of a logical framework. But then the other idea is the resource grammar idea. So one problem with the domain grammars is that if you build a grammar for mathematics and another grammar for weather reports and so on, so they are bound to repeat much of and need much of the same linguistic infrastructure. And because, well, we saw John was showing this pizza grammar yesterday, which is our first example in the book, for instance. And it's very instructive because it shows that even for many very, very simple phrases, you will have to take into account things like agreement and word order and inflection and these general linguistic domain independent things. And this is what the resource grammars are for. So we want to put those into libraries that we can then use in the same way as software libraries, but that people, for instance, mathematician who writes a grammar for mathematical concepts can use these without knowing about the linguistics. But for instance, this is a part of the resource grammar API. I will show more of that in a moment. But you have several ways of making a clause, so you can put together a noun phrase or a verb phrase. This is the most general form. But then you have also special forms where you don't even need to know what a verb phrase is, so you can put together a noun phrase and a verb. Noun phrase, two-place verb and an object, and so on. And then you can, as a domain expert, as they say, you can use this linguistic libraries to build your little translation system. And the trees look very different from these two perspectives. So going back to the sum of 2 and 3, so in our application grammar, which was this little compiler, so the abstract tree is like this, but in the resource grammar it looks like this. So it's you can have some kind of coordination and things that you build on top of that using prepositions and so on. And now I think it's quite obvious that if you want to do translation, for instance, so this is a good candidate for an interlingua for translation, but this is not, because you may have to change the structure of the kind of the low-level syntactic structure when you are translating. So the good translation goes via this rather than via this, but we use this in order to define the concrete syntax in a compact and easy way. So we use it as a library, and then actually the library has the same API for all languages. So you can write in a generic way the sum of something, and then you just to instantiate this to English and Finnish, which in this case happen to have the same syntactic structure. So you just have in the library actually that the possessive in English is of, and in Finnish you have a genitive, bare genitive used as a possessive, and you also have the conjunctions in the library, but you have just, as a mathematician for instance, you just have to define how sum is implemented, what word corresponds to sum in both of those languages. And this is how you write. This is, I think, concrete GF code. Sometimes you don't have the same structure. So, for instance, x likes y. You could write something like this, and then in Italian you switch the subject and the object. You still use the same resource grammar API, but you use it in different ways, in addition to picking different lexical units. So to create a translation system, you define a domain semantics for the abstract syntax, and then you define mappings to each language, the concrete syntaxes. These are the domains that we have in the MOLTO project. Quite a few. I think we had less in the beginning, but we have got some new partners and so on. So I think we will see a little later some examples of some of these. But it's easy to imagine more of them. But then actually, to make this a little bit more relevant to the Apertium perspective, so we also look at how we can scale this up to something which does something similar, or maybe where we could share things. And the baseline that we have, if you want to build an open domain translation, we use the resource grammar syntax as an abstract syntax, as an interlingua, and then we have a large lexicon, a large morphological lexicon on each side, and then an in addition we have a bilingual mapping, bilingual lexicon, and then we just, as a baseline, we just parse source language into a resource grammar tree, we linearize it into the target language, we get something which is by design grammatically correct, and it has the same syntactic structure and as the source, which is not necessarily a correct translation, but one thing that we are interested in is to look at how often we actually have to change it to get something acceptable, because the baseline might still be quite good, and I mean, compared to some other modes of translation. So we will hear something about some preliminary results about this already. But then, in addition, so we see that this will not take us very far. So we are looking at hybrids. So one is to improve an SMT baseline by grammatical information. So Christina and Ramona have worked on that, and I think Ramona will show this. And then the other direction, we have the pure grammar, but we improve it by statistical information. In this case, by, well, not really SMT, but by probabilities from a tree bank. So this is another scenario that is possible for MOLTO that it's a little sad looking score, but as long as we hit somewhere above this arrowhead, then it's good enough. So I thought I would say something about the MOLTO phrasebook, because that's first. This is the kind of the ideal case where we are trying to do perfect translation, and I think it also attaches to some of the actually many of the questions that Martin presented yesterday. We cannot solve them all, but we can solve some of them in this little domain. So this is also a demo for non-technical users, and we have an Android application that Gregoire has built with Ramona, and we have a paper which is, well, appearing. It's in a controlled language setting. And here the idea is that we have this notion of controlled language, but we generalize it a little bit. So it's no longer just for technical domains, but we use it for everyday phrases. The normal controlled languages are unambiguous. They are designed to be unambiguous, but we cannot maintain this in a multilingual setting. We rather have an ambiguity management. And then from a monolingual setting, we generalize it to many languages. So here is an example of ambiguities. And in the phrasebook domain. So if you, for instance, ask you take the German word bitte and you ask what it means. how you translate it. So you see that there are 3 different places where bitter is. Okay, bye. And
every English person knows bitter is a kind of beer.
oh, ein bitter bitter.
Yes.
In Saarbrücken they say ein bit bitter.
Ein bit bitter.
Yes. Yes. But you see, this is actually also an example of these semantic grids, so they go in different ways. And here the disambiguation, at least in theory and also in informal practice, it's quite simple. You think about in what situation you are in the conversation. And here, for instance, interestingly, Swedish also has ambiguity for tack, but it's different for the German ambiguity and so on. This is another even more everyday example. So how you translate you. For instance, one way to test Google Translate is if I translate Swedish to German and I use the plural or polite you, it always comes out as a singular you in German because it first goes to English. Things like this. But here we of course want to take care of all the distinctions. So because, for instance, in a tourist phrasebook situation, it can be very important to use it correctly. So here the disambiguation can be in the context, sometimes grammatically by agreement. You are students, although not always. For instance, if you say you are nuts, then it doesn't work. Or you are a couple, then it can also be plural. By surrounding sentences, by speech situation, about knowing something about the hearer and the speaker, for instance. It may need interaction if you use it in a translation system, so ultimately we may just need to display the alternatives to the user, and that's the disambiguation strategy. So here is how it can be, and it's implemented in the phrasebooks. You have several abstract syntax objects for you. In English, they all linearize to the same, and in other languages, again you have the grid that goes in different ways. But then you add one component, one more concrete syntax, which is an English disambiguation grammar, which is similar to English grammar in almost all respects, except that for the things that are ambiguous, you get a kind of feedback string which tells you that do you mean familiar or polite? Do you mean male or female, and so on. So, and then when the user wants to translate "Are you Swedish?" and here you have the "Est-ce que" question in French, but it comes in 4 different variants here. We don't have even plural singular here. And then if you use this as a phrasebook user, then and you want to translate this into French, then you should choose as a function of who you are talking to.
Do you have this on Android phones?
Yes.
You should use the camera.
That's the next step. Yeah, very good. Very
Hold
good.
the camera up
Yes.
to the person.
There are 2 cameras because you have both.
Yes.
Cameras both ways.
You should use the pictures in the context correctly.
Yes.
Whether you know him or not.
Yeah. Yeah.
That's wonderful. And they can, again, the ambiguity can, because we don't want to bore the user in the ambiguity that is not in the target language. So therefore we group those. So in Italian, for instance, this is just 2 ways ambiguous because the adjective svedese happens to be not invariant for the genders. Then you need to do some compile time transfer, some examples for the name relation, being hungry, how old are you? This was actually the rule that gave a lot of variation. So how far? Because in Romance languages, for instance, in French and Italian, you don't even have the construction how adverb, how adjective, but you have to rephrase it in some way. And in Italian, you even have a special verb for this. The other thing that we need to do to translate properly is that, for instance, we speak about the different kinds of places, like the bar and the station, and be in the bar or at the station. And then we need to store in the lexicon some information about what prepositions you use, and this we have to do in different ways. So, for instance, in Finnish, it affects many things, but you can specify it in a uniform way. So we use a record as a linearization type to collect all the specific lexical information. Some statistics. The phrasebook has 46 categories and 371 functions. That's how we measure the size of a grammar. But then, of course, if you, for instance, expand it to context-free rules, then you probably have hundreds, you have thousands in most of those languages, or even more. Not so many lines of code, because the resource library is used. And actually, the amount of code needed is almost the same in all languages, because the resource grammar just has the same API for the languages. These are the languages. This is some statistics. We claim that we want to make it easy. So some of the languages were made by programmers without any knowledge of the target language, but we are using informants at the development and test phase. And we also used Google Translate to bootstrap some of the translations. Sometimes this was also a test for the resource grammar, so somehow, depending on the maturity of the resource grammar, we had to make some edits there. This is the effort, so one hash mark is about 1 working day, and so totally we need something like 2 days per language to build this phrase book. The automation by using Google Translate, or also by using a native informant, is that you have an abstract syntax tree. Well, the grammarian sees this, and then the grammarian uses the English grammar to give an English example, which is a typical usage of this predicate. Then you give it either to Google or to a native informant. You get a German translation. You parse it in the resource grammar. You get a tree, and then you use this tree as the concrete syntax rule. So that's we call example-based grammar writing. And the rationale for this is that SMT, well, especially SMT, but maybe also native informant, so it's very reliable with short and common sentences. But SMT here is bad for long sentences, especially in languages like German. But GF has rules for those combinations, so once you know how the like predicate is linearized, then you can put it into any combinations by using the combination through combination rules. So this was the workflow for these experiments. It was Ramona who made most of these experiments, and we had lots of informants working a couple of hours with us. The Android application, so it is on the market. It uses this portable grammar format, which is the machine language for GF, which has both Haskell and Java and C interpreters, so that you can run it on different platforms. There is a web application, and I think Thomas will demo the translation system, so you will see it then. Then I wanted to conclude about telling what there is in the resource grammar. So the goal of the resource grammar is to implement and encapsulate low-level linguistic details. And low-level here means the same thing as in programming, that it's the kind of the details, which in practice need the most expertise of the programmer because they are very tricky and special knowledge. So for us, this means complete inflectional morphology plus a comprehensive syntax fragment. And we should hide this all behind an API, which works like a software library. We can also use the resource grammar as syntactic parser for testing and for the example-based grammar writing that I showed. But as the latest thing which has come just very recently, we also use it for open domain translation.
Confused, there seems to be a conflict between the words comprehensive and fragment.
Yeah, okay. Comprehensive part also. So yeah, yes,
Comprehensive
okay, yes.
suggests
or a big fragment. Sorry, I was using a too fancy word. Yes. Of course, this should be open source and sharing and reusing linguistic knowledge. I think when I was working on this at Xerox, we were using Xerox morphologies, for instance, for Finnish, plugged in with GF. But then it was not possible to use them after I left Xerox. So that was somehow by the accident and necessity that we had to start developing morphologies. And otherwise, this might not have happened. There are some other systems or grammar sets that have the same purpose and idea. So, in particular, the core language engine, which you might know about from the 90s, which is yet another resource that is not open and which has just kind of decayed because of bit rot. So maybe it's not even. We had many people who worked on this, and they tried to get licenses for us in order for us to benchmark it, but it was never possible, and so on. But CLE partly is surviving in the Regulus project of Manny Rayner, as you may know about. So he has a set of resource grammars, but he is specializing on dialogue systems. There was obviously the Lingo Delphin grammars in HPSG, which is also, so the boldface things are open source. Then there is Spargram in LFG, not open source. And then there is, of course, Apertium constrained grammars and Lexicon. So that's another goal here is, so to say, we started the resource grammar with English, and then I think Swedish and Russian were the next languages. And I was very surprised that you can actually share the same abstract structures, and then we started to see how far can you get in this way. So it was a kind of a scalability test. But also you can see it as a formalization of linguistic universals. So even though you cannot have universals, say, I don't know, maybe you can have universals in terms of SOV or whatever, such things that belong to the concrete syntax. So maybe you can have universals saying that certain abstract structures are represented in languages. But that's more like an experiment. It also makes it possible to compare language complexity. So you can see, for instance, how big the tables become for the same structure in different languages, how much code you need to describe that. So we wanted to, as a theoretical goal, see how far one can get in this way. So there are some statistics. We have started 36 languages, and some of them are in the nursery and some in the incubator. 25 in the trunk, which means that they have the complete syntax API. Well, maybe this is the trunk. You also have large-scale dictionary, kind of tens of thousands of lemmas. We have had at least 40 contributors, and implementing this for one language is, in the beginning it was a couple of years maybe, but now it's down to 3 months usually for a master's student. It's a perfect topic for a master's thesis.
That's what we say as well.
Yes. Good. So I also measured the code, but it's, the grammar again. The interesting part is actually that the source code size is very similar to the different languages. So here is the status of the different languages that we have, and now I saw that we have Norwegian is the, where is it? By the way.
Cindy Nor.
There is, okay, so there was some copy error, so this should be Norwegian. Bookmall, so it should be Nob. Sorry. Shouldn't have mentioned that at all. So this show what MOLTO applications we have in each of them, and where you have the dictionary, and where you have the smart paradigms, and where you have the phrasebook, and so.
So, and so the master's thesis, whatever it was, that size, was that for one of these applications, or was that for a large coverage grammar?
That was for the large coverage grammar.
Okay.
Yes. But it's the large coverage in terms of syntax, so, and the inflection engine, but to get the lexicon, so that might be another master's thesis, or it's a simple dump from some existing resource. So it's yes. The dictionary, as you see, we don't have it for very many languages right now. But Japanese was actually the latest resource grammar, which was made by a master thesis by a very bright student who really seemed to have. I mean, she had to solve problems like, as we said, putting an round block in a square hole, or if this is Japan. So, because the abstract syntax is kind of Western oriented, but still it was possible to make this in a compositional way for Japanese, which was still, well, yeah.
You never know. Do you know
Yes.
how to say in French, that's not kosher?
That's not kosher.
You know what kosher means? That's not
Yes.
the proper, what's not the way you're supposed
Yes.
to do it. That's not kosher. In French, ce n'est pas catholique.
Okay. But it has the same structures. Only the word. Nice. Okay. So, something about the paradigms, because there was some interest to the smart paradigms. And this will be based on, I will show some of the slides that, where do I have it? Well, I will give the reference soon. So, what is a paradigm? So, Latin has 5 paradigms for nouns, and quite coincidentally many also Swedish has 5 paradigms for nouns and 4 paradigms for verbs in the school textbook.
I knew it.
Yes. So that's an Indo-European heritage or whatever. But then there is this modern Swedish morphology, which has 235 paradigms. And well, I think French also has 3 paradigms for verbs, but the Becherel has 88 paradigms for verbs, and so on.
Well, most of those
Yes.
88 are suppletive oddity verbs. I mean, they're not,
Yes.
and if you look at any language, there are going to be a bunch of those.
Yes. So, and the question is, first question is how we define what a paradigm is. That was also discussed yesterday, actually. So, we take, first of all, mathematically, a paradigm is a function that produces an inflection table. So this fits well in the GF description. So the inflection table is then gives for each description the corresponding form. The argument for this function is either a dictionary form or a stem. And at least my experience is that if you want end users to put words in the dictionary, it should be the dictionary form and not a stem, because they cannot possibly make the analysis into a stem, so we have to do it for them. It can also be, well, the value is the inflection table, which you can abstractly see as an n tuple of strings. And the n is here determined by the language, so for English verbs n is 5, for French verbs in Becherel it's 51, and for Finnish nouns it's depending on what you put in the table, if you put possessives there and so on, so it can be up to 2000 and so on. So the rock bottom way of doing this is by what Hellberg called the technical stem, which is the longest common prefix. And in this way you could, for instance, have many paradigms for English regular verbs, as you see here. But in GF we rather, well, GF uses a combination of functional programming but also regular expressions. So we define in this way. Well, assuming that we have these stupid categories, stupid paradigms, we have a second order smart paradigm, but we don't even need to go that way, so we can just directly define it here. But you basically here can define a pattern that analyzes the infinitive form and then dispatches to these different paradigms, and you can have just one paradigm for regular verbs. So this works for everything else, as far as I know, except for the stem consonant duplication, which depends on the where the stress is. So if you have...
Also depends on where you come from.
Yes, that also, but even so, if you have vomit and omit, so those behave differently.
For me, they behave the same.
Okay.
These, may I say something very, very peremptory, and you guys should get onto the spelling rule thing. You're missing it. You
Yes.
really don't get it. I wish I had my laptop here. I can
Okay.
put one slide up there that nails this English thing completely.
Okay. You mean including these things?
The whole thing,
Yes.
all that, and
Yes.
all these pseudo irregularities and so on. You need an extra component to the grammar. It's very simple. The rules will all fit on that screen.
Yeah. No, but this is also what we need for English.
I'm sorry, it's a terrible, pale reflection of what you need. I mean, I'm very impressed by all this stuff, but you're missing this one.
Okay, I hope I will learn it tomorrow. Please
I
send.
think Mons.
Yes. So then the other thing which you cannot escape is that you need multi-argument paradigms. So, for instance, the thematic forms of the verb. So in some cases.
Like in lie.
Yeah, that's another. Well, the verb lie, you can have it both ways, and they are
It
two
means
different.
different things.
They are two different lexical
Or
units.
Swedish Slaver.
Yeah, the Swedish has many such things actually. But then the user.
So how do you
sorry.
deal with that then?
I will
Because-
maybe show this because this is what we use as the user API. So if you want someone to add words for us, so they have, for instance, can use any of these three functions for verbs, giving either one or two or three arguments, and two functions for nouns, giving either one or two arguments. And then the information that you need for building a lexicon looks like this. You can either do this manually or automatically from a word list, which here assume that we have the part of speech tags.
But those are ordered.
Yes, you have to know what form is which, or ordered in what way.
So, for example, omit, omitted,
Yes.
but you don't have omitting. Or
You don't need it because it's
okay.
it's
But
also
put-
duplicating.
But putting
Yes, putting that follows from the other. So the default for one syllable
is
verbs
to
is to
duplicate.
duplicate.
Okay.
The problem is with the two syllable ones, but maybe there is an even better wisdom that
This is
But that's ordered. So like if you have one that's
Yes.
regular or irregular, regular,
Sorry, yes.
irregular,
So
then you have to.
it's also so you can read the requested forms from this
okay.
specification. So those
That's it.
have to
Just
come in
jump
that
right
order.
in.
Yes, you could do some pattern matching also for ordering them after the fact, but it's kind of that's not what we do. So very often we build a lexicon by taking some word list and then applying these, and then the interesting question is that here is a paper by that Gregoire and I had this year in AICL was about how good the paradigms are. So how many forms are needed on the average. And I think so we kind of how predictable the morphology is and in a way how fast one can build a lexicon. And I think I will also skip these technicalities. So you can see that we kind of count how many forms in average we need to give for each word. So that's what we count. And we estimate it from having a gold standard, a good verified lexicon that we then compare our paradigms with. And so here is how we calculate. And there is also another thing, namely that if you put all the lexicon in your paradigms, then you can make very good predictions, which would be cheating. So therefore we have also measure the size of the paradigm definition itself and weigh it together with the other results. So which comes out as a generalization of the lexicon complexity. But I will now go to the experimental results. So we had gold standards for and smart paradigms for English, Swedish, French, and Finnish, a kind of ascending order of complexity of morphology. We were looking at nouns and verbs, and then measuring some things. So here you have the different parts: English nouns, English verbs, Swedish, French, Finnish nouns and verbs. The number of forms that you have, the number of entries we had in the lexicon, then the average cost, how many forms you need, how many words you get right with just one, and how many you get with two, because two is still a kind of number of forms that you can easily ask someone to add, but if you ask for many more, then it becomes more and more complex. So some things here is that for many cases we are way above 90%, which we could say that the word has a completely predictable inflection. Swedish nouns is an outlier because you really cannot guess the paradigm, and also to this belongs to the gender, so you cannot guess the gender normally. So we can only guess it for some kinds of words. But then if we add another form, then we get quite high. the code complexity. So this is now the abstract measure. We have the measure of the size of the GF source code, which is kind of if you multiply this by 5, then you get the measure of the source code in bytes. So this is the most important manual work that we have done to implement the morphology for the different languages. Then you can use this to see how good the smart paradigms are as data compression. So here we have the size of the full form lexicon in what can this be? Kilobytes, I think. The bzipped size of the same text file. So this is the compression rate that you have, but by bzip2. Then we have the GF code size, which now includes both the smart paradigm applications, the lexicon, and the definitions of the smart paradigms themselves, because that's what you need in order to do the decompression. And here we see that the compression rate, well, for English nouns it's slightly worse than for bzip2, but for all other, yeah, and for French nouns also, but for all other cases it's really much higher. So for Finnish verbs it's really high. So some observations: compression rate improves as the number of forms increases. That's kind of quite easy to understand, because then you have many forms in Finnish, but they are kind of repeating the same. You can guess most of those if you know a couple. The joint compression for the Finnish verb lexicon is quite good if you combine those. So the compression rate, this was something strange here, so I think, yeah, so here actually we have 102 forms, but the compression rate is 114. So it means that this is because some of the verb forms are much longer. So that's just... So then the last thing, I know I've been speaking quite a long time. So we have the syntax categories working in this way, in this kind of a hierarchy. So we have some simple rules for building texts, but then we have phrases of different kinds, like questions and so on, and sentences built from smaller things gradually. And there is a documentation for the syntax in the synopsis document that I will show as there is a demo for that, where you use a part of the resource gamma for parsing. So if I show that first, it's actually a little bit hidden. I go to minibar online and then I have the resource demo, and then I clear this. So let me write something. So now I have this little text lexicon that has a few hundred words, and then the first thing I can see is all the possible first words that I can start a sentence with. For instance, computers are heavy. And here we have some strange things because of the definiteness. You would expect a definite article in many languages, which you can.
Why do you have the partitive in French? Des ordinateurs.
Yeah, so that's.
Do you say that, or les ordinateurs?
Some.
Yeah.
Yeah, there's an indefinite. Yes.
The
That's the index.
French one.
Liaison, yes.
Wouldn't it be Ré?
Yeah.
Then something that you can do now is that you can click at this and you can change this to something which is, for instance, is feminine, for instance, and then you get the agreement for this new subject. And then you can see things like see it. You can see visualizations of these trees. So oh, you're wrong. In Catalan, should be pesats or
Pesades, I think.
oh. And
yeah, that's wrong.
good. Then you have the.
This always happens when you're doing examples.
Yes.
There's bound to be errors.
So you can get the word alignments and things like this. So that's Thomas will say something more about these tools. Then we have the library synopsis, which is the main documentation used by the programmer. So here you can find all the syntactic structures and their functions. So let's go, for instance, and look what different kinds of clauses you can build. So you have the function name, the type of the function, and then you can hover above the English example and you get the other languages. So you can just go and play with that if you want, and report all the errors. We also use this as the first test set usually that we. Okay, but now I think I have spoken enough, and we might have a little break and then continue with Thomas. If you want to have a coffee or something.
Okay. How do we fix things?
Fix what?
The Catalan spelling.
Okay, so we could have as an. Yeah, we
And
could
also work out why. In
We
French
could
as
also
well.
work out why it was wrong.
Yes.
So, yes, that's a good
What do you
exercise.
use for Norwegian generation or the morphology of
Yes, I have it.
Norwegian?
It's interesting.
We have
I'll
rules
do-
that we have written.
About
Yeah,
that.
okay. So I found a mistake.
You found a mistake also.
There's a full form list that you should be able to use to test your rules.
Okay, that's good. Yeah, so we should actually start to use those lists wherever we find them. Okay. There's also some more Thai food if anyone wants in the
Do you
fridge.
know the schedule and how much time the presentation should be? Or at least the order and some.
Yeah, so I think it was about a quarter, I think.
Yeah, I think
Yeah.
15 minutes.
Okay,
2:30 and then we have
but
one for
is the order the one on the website?
I think it's a good order. Yes, isn't it?
Okay, oh, I had that order. Where am I?
Where did you have it?
Yeah, right. The second
On
after
the
Thomas.
RBMT by the Orfeo Talks. Where am I?
Yeah, you.
This
are
is
here.
this is the RBMT webpage.
So you are after Thomas.
Hmm.
You-
Okay, okay. But it's good to know.
Yeah, on
Forgot my
Virgin Wikipedia, if you want the full form list in Norwegian, just look for Norsk Ordbank.
I want to-
At the very bottom,
Yes.
there's
Take it to my computer to charge it.
there are links. I think the best download.
Pardon?
It's not using
This
regular
one
USB.
will give you the full form list straight.
You have the Apple thing in it.
Um, so yeah, and that's very easy to read list.
Okay,
This is just,
Yes, now we should really start using it.
Yeah, yeah, and I mean even if you just use it for validating the rules you
Yes.
have, it'll be
Yes.
really useful.
Maybe you don't know what is this. This is a
Log the ladder.
Yeah.
This is e-type. Then there is some.
No,
It's our 1, 2.